Now let's have an overview of structural analysis. All of us know force. Force is some point of application which has certain magnitude and certain direction. When we apply force at a particular point, it has a direction where we want to apply it, and it has some value. Moment, when two forces act in opposite direction separated by certain distance, then moment is created. It is denoted by the sign what is shown. The unit of moment is kilonewton meter, and the unit of force is kilonewton. Under equilibrium condition, what is equilibrium condition? When you are analyzing any structure in two-dimensional case, in that case there are three equilibrium equations. That means for a static structure, whatever force is applied on it, the summation of forces and the reactions will be zero in x direction and also in y direction, and the moment will be zero. So summation of fx, summation of fy, and moment. This will be zero in case of two-dimensional structure. In case of three-dimensional structure, we have six equilibrium equations. Force in x, y, z direction will be zero. Moment in x, y, z direction will be zero. Let's understand some basic types of forces. When we have a structure and load is applied over it, the load what we apply on the structure, that is called as external load, and because of those loads, the reactions what are generated, that are called internal forces. So these all are forces, external forces and internal forces. The load what we apply is the external force, and the reactions what we get is the internal forces. Like in the figure you can see, F1, F2 are the external forces, R1, RL are the reactions. Also you can have force as a dead load, live load, wind load, seismic load, or temperature, based on the force which is coming on the structure, whether it is force due to dead load or force due to any live load on the structure, or this is the force because of the wind, or this is the force because of the seismic activities, or we have forces because of change in temperatures. So these are some of the type of forces. We know support conditions. There are various kind of support condition and how they are represented in the figure and how actually they are on site. We have roller support, which is represented as a triangle and maybe two dots in the bottom. Then we have the pin connection, which is represented by this triangle. We have fixed support. We have simply support. So these are some of the representations of support condition. I will just show you a free body diagram of these. For a pin connection, we have RY, RX. If it's just simply placed on a platform, then we have RY, RX, and also some friction. And also this is a triangular way of representation of support. We again have RX, RY. Again, for roller, we do not have reaction in X direction because it is moving in X direction. For fixed condition, also there won't be any rotation at the fixed condition. That is the reason there is also some moment generated. That is the reason we have three reactions, Rx, Ry, and M. See, we have this truss. Force is acting on this truss. Because of the force acting on this truss, for a pin connection we have Ax and Ay. For a roller connection we have By. Yes, you can see the free body diagram of the cantilever structure. We have the X, Y, and moment generated. So these were just an overview. We have already done these in detail, but just to start with it, I wanted to have some overview of what structural analysis was. Like when we want to apply point load, we have just P. For UDL, we have W, which is represented by the figure. For a trapezoidal load, we have WA at one end and WB at the other end. For a moment, we have the direction of moment M1 at a distance, particular distance A. Loads and load combinations. What are various kinds of loads? We have dead load, live load, wind load, seismic load, snow load, thermal load. And load combinations, we could have a factored load of combinations when we use partial safety factors. We could have service load combinations when we do not use any load factors. So factored load combination and service load combination and strength load combination. So this is the table all of us have seen in also IS 800 and also in IS 456. In IS 800, it is table number 4. You can see for various combinations of load, we have limit state of strength and limit state of serviceability. So for serviceability, we have the factors shown as below in the table, and for limit state of strength, we have other factors. So when we are calculating the strength of a member, when we are calculating the maximum capacity of a member, we use the limit state of strength. And when we are calculating the deflection of a member in serviceability, what comes? We have cracks of a member and deflection of a member. So generally in case of steel, when you want to calculate a deflection in a particular beam, in a particular member, we go for limit state of serviceability because deflection is a serviceable criteria. But if we want to calculate the bending capacity of a beam or a shear capacity or the axial capacity, you go for limit state of strength.